Hello, everyone, and thank you for joining today's session. My name is Irina, and I'm the Redmond Reactor event planner. Before we get started, I have a few things to go over. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience as well as our presenter. We do encourage engagement in the chat. There you will also find useful links. This session is recorded and will be available on demand in 24 to 48 hours on the Microsoft Reactor YouTube channel. Which brings us to today's session. This session will run approximately 1 hour with questions throughout, and our speaker today is Jim Bennett, who is a regional cloud advocate. I will now turn it over to Jim.
Awesome. Thank you very much. Hello, everyone. Good morning, good afternoon, good evening, good night, wherever you're on the world. Welcome to this stream. Now, this is a part 2 of a 2-part series. Last week, we got started with Azure Sphere, the secure computing board from Microsoft. Today, we're going to carry on working with our Sphere board and actually get data up into the cloud and have a look at how we can secure network access, hardware access, things like that. So as I say, welcome to the stream. Please, if you were here last week, let me know in the chat. It'd be good to know whether who's come back. And if you've done anything with Azure Sphere, again, please let me know in the comments or in the chat. I'd love to hear what you've been doing with the board. Now, we've been working through a Microsoft Learn module. Microsoft Learn is our online self-guided learning platform, completely free. So anybody can use Microsoft Learn to learn how to use all the various different all the various different bits and pieces that Microsoft offers. So in fact, what? Let's just bring it up. docs.com/learn. We've got loads and loads of cool stuff on here to teach you all the things. And in particular, I was working through this module here. Let's go back to the start of the module over here, which is all about developing secure IoT solutions for Azure Sphere using Azure RTOS and Azure IoT Central. So this is what I was working through last time. It's part of a whole course all about AI, cloud and edge that's been built in partnership with the University of Oxford. And there's a lot of great stuff on here to teach you how to get going with cloud and the edge. And so this Learn module was all about Azure Sphere. So there's no cost to doing the Learn module. Microsoft Learn is completely free. The only kind of cost, as it were, is for the hardware. And the hardware we're using is this Azure Sphere MT3620 starter kit. So we played with this last week. But I showed you. Here it is. This is my starter kit here. It's got the Azure Sphere chip in here, which is our secure chip that allows us to securely connect to Azure services. And then it's got connectors to plug in all the other bits and pieces. And it's got buttons and LEDs and sensors and all that kind of stuff built in. It's quite a cool little board. And it's connected to, it works with Azure Sphere. So it's a secure computing device. Now, just for a quick overview of Azure Sphere, just to kind of go back to where we got. We worked through this Learn module. We talked about how Azure Sphere is made up of Sphere certified chips. Lars Dreher, hey there, how's it going today? Great to have you here. So we talked about what makes up Azure Sphere. So we have the Sphere certified chips, like this one here. This chip is certified by Microsoft as an Azure Sphere chip. It's got security bits and pieces on board. We have an operating system that runs on the chip that's secure. And then we have secure services in the cloud that the Secure OS talks to, and that manages everything. Now, these chips actually contain 3 cores inside them. So they have a Linux core that runs the Azure Sphere operating system. This is not a real-time core. And this does all the networking, all the communications with kind of the outside world. And that runs the Sphere OS. And then on top of that, we have 2 real-time cores, less powerful, but real-time cores. And they run your code that interacts with sensors, actuators, other devices, things like that. And then there's kind of firewalls in the way that allow or deny the communication between the different components. So the idea is you would have one core that talks to hardware. It would then pull, data from a sensor, do things like that. And then it'll send that over a message bus, if it's allowed to the Linux core, which then connects that to the cloud and sends up the cloud. So Lars Dreher says, how will my LED light bulb fit a chip of that size? Will my light DDoS me? distributed data service me if we're talking security? Yeah, great question. I don't know how small these Azure Sphere chips can get. That's actually a really good question. I've got another Sphere device here, but again, it's the same thing. I'll just go over to my camera. It's a sizable chip. I mean, yeah, I'm zoomed in here, so it's not as big compared to my finger for size. So it's a sizable chip. You wouldn't put that in necessarily a light bulb, a chip in that size. But maybe just thinking about kind of security side, thinking about things like, there's certain light bulbs that come with like a hub. So they communicate over Zigbee, and so the light bulbs themselves are not connected to the cloud. They communicate over protocols like Zigbee to a hub. In that hub, you could put an Azure Sphere chip. So if you think about securing smaller devices, you could almost kind of take this idea we've got of inside the chip, I've got my real-time core that with my secure OS, and then my non-real-time core with secure OS and my real-time cores, and those real-time cores interact with sensors and actuators. You could kind of take that real-time core away, put it in a device that connects remotely. Obviously, there's still security risk because you're connecting over potentially insecure protocols. But yeah, kind of maybe I guess that would be the one way to do it. You'd have the secure chip inside a hub that you connect to. Either that or bigger light bulbs. I mean, you can't really get at the LEDs like I've got these teeny tiny LEDs up here. Couldn't do it in those. But if I look at the light bulb above me in my office, it's kind of sizable bulb. So you probably could actually get a big bulb. You could put it in there. But yeah, otherwise, yes, you'd put the secure chip inside the hub, and then devices would connect to the hub. Obviously, there's still that device to hub hacking, but that's kind of local. So somebody would have to come into your house to hack your Zigbee rather than be able to do it remotely. A remote hacker in another country couldn't hack your bulbs because they'd have to go through your hub. So kind of that security by air gap almost. Someone would have to be close enough to use your whatever protocol is being used to go from the secure hub to the devices. Great question there. Great question. I'm not a security expert. I'm very much learning as I go. That was kind of part of the aim of this is I want to learn Azure Sphere of security. I've seen too many IoT horror stories that I don't have as many consumer IoT devices as you might expect for somebody who talks about IoT as much as I do, because I've seen too many horror stories of what can go wrong. It kind of puts me off. I was doing some Bluetooth scanning for a device I was building for another stream yesterday, and just the number of devices I can see around me to kind of get an idea of what people have got, and I could probably hack. It's kind of a bit scary. So yeah, this is what I want to learn about security. But no, great question. Great question. How do we make light bulbs secure? So this is kind of the architecture we've got of the chip that we were talking about last week. We've got the security subsystem. We've got the Cortex A7, which is our low power Linux-based core. So that doesn't interact with your hardware. All these firewalls, then you've got network connection, and then your two real-time cores for real-time processing that talk to the hardware. So that's the chip. Developer tools wise, there's an Azure Sphere SDK that runs on Windows or Linux. Anyone who knows me knows I'm a Mac person. You can be, I'm a Mac. So I am remoting into a Windows box. I've got a Surface Book just there that I'm remoting into to do everything. In fact, look. Oh, it's a Surface Book. So that's what I'm remoting into to do everything. But yeah, so it doesn't work on Mac OS. There have been requests for it and people trying to port the libraries, but they just don't have Mac OS support at the moment. I just guess enough people haven't asked for it that we have that support. So there's developer tools that we need to put on our device. And then the aim of this Learn module that I'm working through, which has just been put in the chat. If you look in the chat, aks.ms/secure IoT Azure Sphere, that will take you to the same content that I'm working through. And so the idea of this is we're trying to build a lab environment monitoring system. So in a lab, we need to monitor temperature and pressure. Used to be monitored manually. Now we need to do it via an automated system. And that was what we started working on last time. And where we got to last time is we set up IoT Central, ready for our device to connect. So working through this section, connect Room Environment Monitor to Azure IoT Central. And we did some stuff with certificates. So we set up the IoT Central application, and then we created a device connection group for device enrollment using a certificate. So we got a certificate that we generated, we deployed that to Azure IoT Central, and we verified that certificate. So now we know with this certificate, any device that has our certificate on it will be able to connect to IoT Central and send data, but only devices with that certificate. So we don't need to manually define these devices in IoT Central. We just connect from our device with the certificate, and IoT Central will provision that device for us automatically. But only devices with our certificate can do this. Now, we've only got one certificate here. Ideally, you want to put two certificates on there, because if one certificate gets compromised, you can then revoke that certificate and then get the devices to flip over to the second certificate. So devices, when they connect, you can actually say connect with two certificates and then try them both, see which one works. And then what you can do is if you need to revoke a certificate, you revoke it, and then you could push a firmware update to your devices with a replacement for that certificate. So you kind of got these two. If you only had one and that got hacked, you've got no way of defending against it. Two gives you the chance of, if only one is hacked, you've still got the second. Both are hacked, all bets are off, but it's kind of just adding more layers of security. Nothing's perfect with security. It's trying to get as good as, and then keep pushing that as good as limit as far as you can. So that's where we got to. So now what we're going to do is take our Azure Sphere device, think about connecting it, and actually connecting it to Azure IoT Central. We already had it connected to the internet. We did that last time. We connected it to my Wi-Fi. I think I can't remember. It's been a week. This is my third live stream in 24 hours. So it's been a week. So let's see where we get to. So this unit, we will learn about Azure Sphere Security. So applications in Azure Sphere are secure by default, which means you must grant capabilities to the application. And this is key to the security of Azure Sphere. It's known as the principle of least privilege. So this is the idea that you start off with no rights to do anything, and you only get the rights you need to do something and no more. If any of you worked in corporate environments where you don't get admin rights on stuff, you just get an account that allows you to just do your job and no more. This is the principle of least privilege. Developers hate it because we want admin rights on all the things, but it's a great way to stop mistakes happening and stop hackers doing things. So the idea is every account should have the least amount of rights that you need and no more. And if you don't need a privilege anymore, you don't need access for something, take it away. So it's that principle of least privilege, and that's what we're doing here. And so the capabilities we've got include what hardware can be accessed, what network endpoints can be called, and what intercore communications are allowed. So we can define the rules as to what sensors on our board can be accessed by the code. Maybe we can have one core that can only access a temperature sensor, another core that accesses a humidity sensor. Maybe we need to keep them separate. What network endpoints can be called? We can define we can only connect to this endpoint. We can't just hit anywhere on the internet. We can only connect to our IoT Central application. We can't be hacked to connect to a command and control server somewhere else, which is not allowed. Only one networking endpoint. And then what intercore communications are allowed? It could be we're only allowed to send messages to one real-time core because that controls a light, like Lars Drier's lamp, for example, his light bulb. We can only send to a core. So that way, if that core is hacked, we can't receive any messages that comes from that core. So we're kind of defining this set of rules about privilege. So we start with network endpoints. So we have to declare all the endpoints our application will use. And if you try and access an endpoint that's not declared in your application, it will fail to connect. So you get this kind of network firewall. Same as on your firewall at home, you can say, don't let me connect to this. Don't let me connect to that. Same kind of thing. And you can't. And so it's done as a firewall, it can't be changed, the device is restarted. So if you do need to change the firewall, if you've got another application needs to connect to, you can update that in firmware and restart the device. But it can't be kind of updated as the device is running. And so when we connect to IoT Central, we've got to declare the device provisioning service and the IoT Central application endpoints. So when you connect to IoT Central, first of all, you connect to a device provisioning service to say, hey, allow me to connect. And then you get back an underlying IoT hub, which is like the message broker connect to, and then you connect to that. And so our device needs to be able to connect to the provisioning endpoint and then all the underlying hubs for IoT Central. So Lars Trier says, how do you check if your command has been executed if you don't allow RX? So how do you check if something is done if you don't allow communication? That's a good question. So I haven't dived into that communication between the cores. I assume you mean if the core sends the non-real-time core, the Linux core sends a message to a real-time core to say, turn a light on. How do we get that kind of response on the message? I guess we'll find out. I guess we'll work that out. I haven't got that far yet. I don't really know how that works. So we'll find out as we do this. But yeah, great question. We want to limit communication, but we've got to allow for the response to come back. So I know it's done via messages. So maybe the underlying implementation allows a response for the message. Yeah, so I can pass a message to you and I get an ACK to say that you've got the message, but you can't pass a message to me. It's kind of like a one-way message broker. So yeah, we'll dig into that in a bit. We'll find out. But yeah, great question about how it's kind of implemented under the hood. Good question. We'll dig into that. And Abadou says, I like the stream description. The S in IoT stands for security. It really sums it up. Yes. Security has been very lax in IoT devices for a long time. That's where this is an old joke that the S in IoT stands for security. You just Google with Bing for IoT hacks, and it's just scary. Just how many hacks have happened because of the lack of just basic security. Yeah, this idea I'm saying about the principle of least privilege, that's not something that a lot of devices have. They're just open. And if it's not the device, it might be where the device sends data. So there was a case where there's a kid's toy would record messages from the kid and speak to the kid and capture pictures, and they were stored in an insecure cloud storage. So anybody who knew the endpoint could go onto cloud storage and pull back everyone's data. So there's so many security holes that you see. Yes, Abadou says, I'm always reminded of the fish tank temperature sensor, allowed access to the casino high roll list. That is my favorite hack. Talked about this last week. A smart thermostat in an Atlantic City casino had an open wireless access point. Hackers connected to that. From there, connected to internal casino networks and pulled data off. So again, the principle of least privilege, the thermostat was connected to a internal network that had access to all the other things. It should have been on a separate network because it was just reporting the temperature data. Should have been on a completely separate temperature on a completely separate internal network, so that it can't catch internal data. So there's kind of operations folks, when they're managing network access, need to be involved in IoT deployments to stop this. So I wasn't sure if it's real or not, but you just confirmed it. Oh yes, it is real. Atlantic City fish tank hack. Here we go. Here's the Forbes article on it. Yeah, it's a real thing. It is my favorite hack. So yeah, it allowed it. There was the open Wi-Fi so that the device, so a hacker connected to the thermostat. The thermostat was an internal Wi-Fi network, not an isolated network. And then there was no blocking to actually allow to stop data being sent outside the casino. So there's so many security fails in somewhere where, you watch these heist movies and they've got all these security folks everywhere, watching George Clooney try and steal millions of dollars. And yet someone came along and just, hacked it. Yeah, 10 gigabytes of data was lost. Don't keep fish. No, keep fish. Just don't connect your smart thermostat to your internal casino networks. Again, it's principle of least privilege. Your device is connected to a network that had too much access. So, yeah, principle of least privilege. Or just get artificial fish, IoT fish. You don't need to connect to anything. Okay, so in our application, when we build our Azure Sphere application, there's an app manifest.json file, and there's an allowed connections section where we can list the endpoints allowed to connect. So when we compile our code, we actually put this limit on to say, this is where you can connect to, which means you cannot connect to a hacker's device in the casino, and you can't connect to wherever it was they're going to send the data. We put these physical limitations in our code. And then same with access to hardware. So Azure Sphere applications are secure by default, and you must declare access to hardware peripherals your application requires. If you don't declare hardware, application will fail when it tries to access the hardware. So it's implemented in hardware as a silicon firewall. So there's literally a sticky firewall that's there that blocks access until the device is restarted. So if you need to add a new sensor, update the firmware, reboot the device. And again, you have a capabilities section where you can define what is allowed. So for example, on the GPIO pins, we're saying we can connect to button A, a network connected LED, and an alert LED. So this can, a button, the LED that lights up when we're connected to Wi-Fi, and an LED that we can light. Or if we're connected to I2C, we can connect the I2C master 2 bus. So there's kind of these limits on what you can connect, and you define those. So we're going to be using it as some labs that have been provided, and they've got all this stuff in there. So let's actually do an exercise. This is how Learn modules work. We say, they tell you this is how we're going to do the stuff, and then we actually do hands-on. So let's actually do something. So last time we cloned we cloned some code, and we need to actually find, so we need to use the code that we've cloned. We need to find a little tool. So what I've got here is, where did I put it? I put it in here. Let's do this for a good old-fashioned terminal. So there's a little tool that's been provided, allows me to get the network endpoints. There's a tool that's can connect to IoT Central and pull out those different network endpoints, because I need to better connect to it. So I need to define all the endpoints that I might connect to from my Azure Sphere device. So if I just go into samples, and then samples, Azure IoT tools, and 64. There's a tool in here called Show IoT Central Config. So that's what we're going to run to connect to. Show IoT Central Config. Right, so this is going to work through our IoT Central application and give me all the network details that I need. Am I using an old one? No, I created it last week. Need the ID scope. So the ID scope is a unique ID for our applications. Here's the ID scope. That's a unique ID for Azure Central application. Put it in there. Enter a real device ID. Ooh, I don't have a device ID, do I? It's interesting. Ah. Okay, this is asking me different questions. That's interesting. Show IoT, it's the right application. I'm not. Let's try that again. And then when it asks if I'm using a legacy one, when the answer is no, I should actually put no. There we go. That's me. I'm not using a legacy one, so I don't know why I said yes. I blame a distinct lack of coffee. There we go. And then we need an API token. So from Azure IoT Central, we can create an API token. This kind of gives rights for me to access my Azure Central. So I'm going to do sphere config. There we go. I'm going to make that app administrator. So generate an API token. And this is a one-shot token. We don't get to see it again. So if we lose it, we're in trouble. This API token allows the tool to connect. So I can go here. And if I get to take my ID scope. So we're doing all this. So this tool. So this tool is run, and it's actually given me some code. It's given me the capabilities and my allowed connections. So what this has done, this has actually gone to IoT Central and said, right, for any device to connect, what is the list of all the things I may need to connect to work with this IoT Central application? And so it's given us a list of allowed connections. So we've got the Azure device provisioning service. So this is where my device makes that initial connection. And then I've got a whole load of hubs. These are all IoT hubs that my device may connect to. So when I connect, the way a device works is it connects to provisioning service and says connect me, and it will get back a connection details of how to connect. And that's going to be one of these things. And so we've kind of got this piece of code, piece of JSON here that we can then use in our Sphere application. So I'm just going to spin up a new document in VS Code. And then just paste that in there. Let's keep a copy of this. And this has got our scope ID and then all our devices. And then I need my tenant ID because we're connecting. If you remember, we talked about last time, you can only connect to one tenant and only one tenant, and that's going to burn into the device. Once you allocate device to a tenant, you are connected. So I need my tenant ID as well to go in there. Samuel, hey, how's it going? Greetings to you in Ghana. Samuel's joining us from Ghana. Hope it's not too late for you. Guess it's probably early evening. But yeah, welcome. Great to have you here with us. Right, so let's get my tenant ID. So I'll copy this, paste that, run that. This will connect to my Azure Sphere device and pull back the tenant ID that I had, the one that my device is hard coded to. And there we go. This is my tenant ID. Let's copy that. And remember, I know we talked about this last time a few times, but it's really got to hammer this point home. When you connect your Azure Sphere device to a tenant, it is a one-shot operation. You cannot change that. You cannot connection with another tenant. Lars Dreer says, have to go. Will there be a recording? Yes, there will. All of the Microsoft Reactor sessions are recorded. If you go to the Microsoft Reactor YouTube channel, they're all available there. So last week's session is there. Today's session will be there maybe later today. If not, it'll be there tomorrow. We usually have a relatively fast turnaround of these videos. But yes, there'll be a recording. And I'm all over the internet at Jim Bob Bennett. So Twitter, Instagram, GitHub, LinkedIn, Jim Bob Bennett. Feel free to connect if you've got any more questions. Otherwise, thank you for joining. It was great to have you with us. Cool. So yes, I'm just going to keep hammering this point home. When your device is connected to a tenant, you cannot change it. So if you make a mistake, connect to the wrong tenant, you've got some basically electronic junk needs to go and be recycled. So you have to make sure you connect to a tenant and then never lose your tenant. If your tenant gets deleted, again, you're left with a big pile of junk. This is if you roll out a million coffee machines with Azure Sphere chips inside them and then delete the tenant, that's a million bits of broken hardware. But that's part of the security. Nobody can hack it and point it to someone else. Obviously, deleting tenants is, it's not something you're going to do on a whim. You shouldn't have rights to do that. Principles of least privilege and all that. But it's just something you need to just keep in mind. You do not want to ever delete your tenant because the devices cannot be changed. Cool. So we've run through this. We've got our output. We've got our tenant ID. So we've got the connections. So this is what we're going to do. This is what we can put in for our network firewall. And so this is what we're going to work on, building a high-level application to stream telemetry to IoT Central. And so the idea is we have our Azure Sphere. It runs the Cortex A7 high-level processor. So that's the one we're going to use to start with, our Linux non-real-time core. And we're going to stream data via an Azure IoT Hub to IoT Central. Now, IoT Hub is built into IoT Central. I'm not going to create an IoT Hub. By creating an IoT Central application, it creates all the underlying hubs that live underneath the IoT Central application. And these hubs are these. So this is the connection details of all the IoT hubs. So we connect to the hub, which is part of IoT Central. So that's how the messages go through. So let's look at understanding the Azure Sphere application, the application we're building. So these labs make extensive use of event timers. So it's a generalized model to simplify working with timers. Event-driven program helps simplify application design. So there's two types of timers, periodic and one-shot. So periodic timers, every now and again, will do something. One-shot timers happen once. And so the event timer has got a scheduler, and then it runs whether if you press the button, if it checks whether the button's being pressed, that's on a timer, blink an LED, measure the sensor, and blink an LED once. So I've got a whole lot of different timers that we can use inside our application. So when we measure the sensor, we define a timer that's a period every 6 seconds. There's a name and a handler. So with this code we can do Azure Sphere programming, C++, well, C in this case, but it's C++ code. We have to get right down to not quite to the bare metal, but close with C++. And so we define these timers in C++. So this is our timer. And the handler is a static function that's called whenever the trigger goes off. So this is kind of the way you do timers in Azure Sphere. And so this would be our handler. And so we have a timer, we define this timer, and then in our handler, we run the timer, and then we can read telemetry. I'm not going to dig too much into this code because I don't really understand it that well. I haven't dug it much into myself, but we can get telemetry. Now, IoT plug and play enables solution builders to integrate smart devices with their solutions without any manual configuration. So the core of IoT plug and play is a device model that a device uses to advertise its capabilities to IoT plug and play application. So the idea is you have a model that says my device can do temperature, humidity, receive a message. You define that, and then you can almost get pre-built firmware you drop on a device, and that will then connect. So in IoT Central, it's like here's a predefined IoT device that sends data. And so there is a model that's already been defined. Somebody's defined a model for this. And so if we use this model on our Sphere device, we say, connect to IoT Central with this model. That tells IoT Central what data is going to be received and allows the device to be set up and configured correctly. So it kind of does a bit of magic for it. It's like a predefined template for this is what the device will send. This is how I can communicate with the device. And therefore, this is what features I need in IoT Central. Right, we'll see it in action. I think that's probably the best way to do it. So let's deploy a high-level application to Azure Sphere. So this is where we're going to deploy some code to the device, just running on the high-level core. And we're going to use some existing code. So if I go to, let's grab a new VS Code window. And then let's open the lab. So rather than write the code ourselves, because it's a lot of code, let's actually, no, it's not that one, is it? It is, let's actually check where it is first. Wrong one. Wrong folder. We want Azure Sphere, and then lab 2. Let's actually do open folder, not open file. Open folder. There we go. So this is all our code that we're using. It's been kind of pre-made for us. Now, I mentioned this last time. I mentioned it again. Things constantly move and evolve, and so sometimes documentation gets a little bit out of date. This is a smidgen out of date. Let's make a couple of tweaks to fix it. The person who wrote this, Dave Glover, is updating it at the moment. But we have this fun of something moves forward a little bit, so we have to then kind of catch up with our documentation. So we're just a smidgen behind on some of this. So we might have to make a couple of small tweaks. So go here. So first of all, we need to configure this Azure Sphere application. And so if we look at app manifest JSON, this is the resources the application requires. It's got to be declared in the capability section. So if I go to app manifest.json, let's just hide that. This is what we've got. We have no allowed connections, and we don't have our ID scope defined inside here. So what I can do, if I go back to what got spat out the tool, very useful tool, just copy that. Go down here for a second. So this is our scope ID. Needs to go in there. And then if I just replace the device authentication, that's my tenant ID here. Drop that in there. and then my allowed connections. So let's take my allowed connections, copy that, and just replace. There we go. So I've added my scope ID. So that way when it's run, it's got the scope ID, so it knows how to connect to IT Central. I've set my tenant ID on here, and I've added all my allowed connections. So if I wanted to make a call from here to, badpersonshackerwebsite.com, couldn't do it. My hacker couldn't do it. If I want to get my data off my fish tank, could only go to IoT Central. So kind of putting that limitation in place. So that's kind of what we've gone for here. Then we need to set up our developer board in the CMake list. So everything's using CMake. And in here, well, I'm using the AVNet Starter Kit revision 2. I think I'm using revision 2. Maybe I'm using revision 1. This is good question. Might be revision 1. Let's do a quick bit of spelunking, see if we can find out which one I'm using. So this is this is revision 2. Notice the bits of hardware. I don't have those bits of hardware. Let's move them away. So I'm using revision 1. So let's go back to VS Code. Oh, I'm randomly clicking things. What did I just launch? Go away. So I'm actually using revision 1. That's me randomly clicking on the wrong thing. There we go. Oh, hey! Don't want you. So yeah, here's revision 1. So that's what I'm using revision 1. So when I update this will go and do some things. In fact, I think I need to reconfigure CMake. So that sets my board. And then need to deploy the application. Now, I actually see I've gotten some errors here. The reason there's errors is because, so this is, things are slightly newer, things have been updated. So I just need to make a couple of small tweaks in here. Where is it? Somewhere here, I actually define my, I think it's in here, I need to define that one. Target API to 12, that's what we're going for. 12, I think that's what it is I have to do. And then somewhere here I define my actual Azure Sphere 12 under here. 2202 is the tools. I think those are the bits I need to do. So all this is going to be redone. Dave Glover, who built this, is kind of updating this as we speak. So that should be it. So in theory now, hopefully, if I made the right changes, I should be able to just CMake debug ready. So make sure we're on debug. Yep, we are. And then press F5 to build and deploy. So drum roll, let's get ready. This should build and deploy to my device. If I go over here, you might see, I stopped doing it. There was an orange light flashing, and now it stopped doing it. So that's compiling. Hopefully in a second, we'll see the orange light flash, and that is everything being deployed. Oh, there we go. Look at that light. Things are happening. LEDs are being lit. This is what we want with IoT. LEDs doing things. Okay, so we're now running and debugging. Cool. It's got the debug console going. We are running and debugging. So look at the debugger output to see log debug statements. There's a debug console. Things are happening. So in theory then, so WLAN AD will blink every 5 seconds. think we just saw it there. There we go. There we go. And if I just check that, I think that's the WLAN light. It's far too small for me to see. So I don't know why they put a box around the button. That's a button, not a light. Okay, and then we should be able to display device telemetry in IT Central. So if I go to IT Central, go to devices, I'm not seeing that's interesting. I'm not seeing my device. Is that auto approve? Certificates up to date. Are we running? Okay, let's just try that again because it hasn't connected. Bit of live debugging is always fun. Let's just try that again. Deploy it again. Oh, network not ready. Okay. I should read the output. Network not ready. So we've got some data that's sending, but it says network not ready. So let's just go to terminal. Ah, disconnected. So maybe I didn't do the, maybe I missed the Wi-Fi configuration part. Okay. I thought we had this connected. So let's find the bit where we do the Wi-Fi and do that again. Maybe real-time development, clean the samples. There was a quick start thing. Maybe it was in the quick start. Configure networking. Okay, right. Maybe I just didn't do the networking part. That's probably what I didn't do. I didn't do the networking part. Device ID. Got my tenant. There's my device. Just do that thing. Okay, Wi-Fi. Disconnected. Save networks. Available networks. Okay. I just didn't do the bit to get the Wi-Fi, I think. So, okay, right. I'm just going to connect to the Wi-Fi. So you're just going to lose my screen for a second while I just type in my network password. Second. Back. There we are. That's better. Now that's connected. Right. Now that's connected to my Wi-Fi. Things are a little bit easier. And then let's just restart the application. Oh, no, it doesn't like me restarting the application. There we go. Now we're deleting the existing application and starting. So yeah, that would be why it wasn't working, because I forgot to connect it to my Wi-Fi. Oh well. There we go. Now we're seeing some output. Nice. Not seeing any errors yet, which is a good sign. So hopefully now, fingers crossed, if I go to here, nope, no devices. Okay. Failed to read LSP22HH device. Okay, I'm not sure what LSP22HH is, but it failed to read from one. I wonder if that's one of the sensors. I just haven't done some sensor configuration yet. That's a pressure sensor. It's a pressure sensor. Okay. But now, yeah, so now it says we're connected and we're sending data. So we're not getting, so IT Hub connection is client connection. Okay, cool. We're connected, but something's gone a bit haywire with my pressure sensor. Could be the hardware's broken. Could be it's older hardware. Mind you, if I look here, okay. Oh well, it could just be broken hardware. But hopefully now, refresh this. And now we've got a device created. So where the certificate was embedded on the device and it connects, I now have my device on here. And it's slowly going to start sending data. Haven't got any data yet. Hopefully that should start coming in. So sending data, it will take a bit of time for that data to kind of appear. Connected. There we go. Device connected. So it takes a bit of time for the data to feed into IoT Central because it comes in from the device into IoT Hub, and then IoT Central's application kind of sits on top. So it's always a few seconds behind. But eventually we will start seeing data appearing. Cool. But we're connected. We've got data. So we've got this secure application that we've built. That's pretty nice. 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 I'm liking this. This is pretty good. Should a minute the rest of the data will catch up. We'll start seeing charts and graphs. Either that or it's just not liking the fact the pressure sensor is sending a NAN. Usually a power cycle will correct this issue. So let's just do a power cycle. Yeah. the good old fashioned way. Unplug it. Plug it in. And then hopefully that power cycle should. Let's just relaunch that. Cool. Yeah. Excellent. So we've got it connected. We've got data. We've got it connected into IoT Central, which is pretty cool. And we've got that secured thing. So if I wanted to write code for this device to go and poll something else, I couldn't do it because, yeah, I've got that limitation on the network points. I've got my manifest. This is my only allowed connections. So we've got that security built in, which is very, very cool. Now, there's a question last week from someone asking about the lifespan of that hardware's broken. Oh well. Ask about the lifespan of the updates for this. You know, if you release an Azure Sphere application, how long do we guarantee support for? So we don't have any documentation on this. I went and spoke to the Azure Sphere team, but our standard is 10 years of support, and then after that we will do security updates and all that. So you know, if you're working with Azure Sphere, particular version of the operating system, you get 10 years worth of support out of it, which is pretty good. And obviously after that, there'll still be security updates and all that as needed, but kind of the core support, long-term support is 10 years, which is very nice. Now, I'm wondering if, because yeah, we're not getting those. Yeah, it's not getting the, I wonder if because our pressure is not a number, whether that's actually not getting it through to, not making it through to IoT Central. It's just not liking that particular, not liking that data. So what I'm going to do is, I wonder where it actually sends that. It's probably better code somewhere that actually sends. Oh, there we go. Message template. Where do we use that? There we go. So environment pressure doesn't like that. So we just put, say, I don't know, let's change that to 0.0. Let's just change that to get rid of the pressure, because I wonder if that's what's causing the problems, causing it to not appear, because it's not going to not liking the message format. Maybe let's try it and see. Yeah. Yeah, we'll leave that running. Let's actually carry on working through the content that we're here for. So next, we're going to learn how to set up a virtual thermostat with device twins. So the idea is we're going to use control an Azure Sphere connected HVAC, heating, ventilation, and air conditioning unit. Control that via IoT Central. So IoT Central has things called properties, and they represent point-in-time values. So you have telemetry, which is data that comes from the device to say, this is my temperature, humidity, pressure. Then you have properties, which kind of point-in-time values, and you can use those to set the state on a device. So you can say to a device, I want the room to be 20 degrees Celsius. And you set that as a property in IoT Central, and that gets pushed to the device. The device is offline. Then when it connects, it'll pull down that property. So it's kind of persisted in the cloud and always available to the device. Now, IoT Central is built on Azure IoT Hub, and IoT Hub uses a thing called device twins, which are JSON documents that are kept synchronized between the cloud and the device, and they can store information such as metadata, configuration, and conditions. And so device twins are often used for long-running commands intended to put the device into a certain state and return to that state after device restart. So the idea being you say, set a property via device twins to be temperature 20 degrees Celsius, and then if the device is disconnected, next time it connects, it'll get that setting, and then set your temperature 20 degrees. If the device doesn't need to persist that on any kind of storage, because if the device is rebooted, on its startup, it'll then connect to the cloud and pull that data down again. So it removes the need for storage on the device. The storage exists in the cloud. And so we can control the HVAC using IoT Central properties. And so there's a tab in IoT Central that allows me to set the desired temperature property. And then under the hood, it goes through the IoT Hub device twin platform to Azure Sphere, where we get the temperature handler gets detected via the device twin, sets the temperature, and we get acknowledgement of the configuration. So just wonder what you... Oh, yes, there we go. So that was the problem with the data, where the pressure sense wasn't working. It didn't like the data. So there we go. There is my temperature, humidity. Ooh. I hope that's not the actual temperature, because 33 degrees is very warm in here. It doesn't feel that warm. Oh well. So this is what we're going to do. We're going to set up RT, so we're going to set the property in RT Central, sends it to Hub. Hub updates the device twin, pushes it to the device. We don't care about how all this works under the hood on the cloud side. We just update an RT Central, gets pushed to the device. We just need to kind of understand a bit about how the device does everything. And also, so we do this with the device twin binding. So it maps a property in the device twin with a handler function. And so we can say, we set this to binding. So when a property in the twin called desired temperature changes, that calls this code. It's kind of a nice bit of binding you can write inside your code. So that way you don't care about processing the device twin. You don't have to say, give me the entire JSON document. Has it changed? Let me know if it's changed. Put out the bit I want. You just say, if this property changes, update the code. It's all built into the Azure Sphere operating system. And then we can use this to set the desired temperature. Now, when we get it set, we have to ACK it. So we have to send a message back to the cloud to say, yes, I've accepted what you've got. So when we run our handler, we get this change in the twin, we get this property value. We will then ACK that back to say, yes, I agree. Yes, I've accepted this. I'm going to set the temperature to 20 degrees, and we set that. And then once we want to report the temperature, we can then report this through the same thing. We can actually, we've got the cloud says, I want you to be 20 degrees Celsius. My actual temperature is 21 degrees Celsius. I'm going to send that back up. So the cloud knows what the current temperature is, and that's kind of maintained in the cloud. Again, you don't have to store it. The twin is stored automatically. You don't have to save that temperature from the device up in the cloud in any kind of storage. And that's, again, we can do a binding to the device twin for a value, and then we can report that value. So kind of a lot of the boilerplate code for managing twins is built into the Azure Sphere OS. So you know what? let's just do it. Let's do the exercise. Let's actually work through what we talked about. Does this mean messages are one-to-many from Azure Sphere? Not sure what you mean by messages are one-to-many from Azure Sphere. Do you mean as in IoT Central can send messages to multiple devices? I mean, yes, definitely. So IoT Central can update multiple devices at once. A device twin is on a per device basis. So when you update a device twin, it is a device twin for a specific device. So if I go into IoT Central, don't know if I've got I don't have a field here to actually set that at the moment. Sent once, potentially read multiple times. Yes, yeah. So a device twin it's not a message as such. It's a persistent blob of data. So if I were to send a message like telemetry that comes from the device to the cloud, yeah, that's kind of like almost like a fire and forget. Yes, you have acts and all that, but it's here's my current state. Here's my current state. Yeah, and when I send a message from the cloud to the device, it can just be here's a message. If you're offline, I don't care, whatever. But the device twin is persisted. That lives in the cloud, and then the device can connect and it can pull that as many times as it likes. So kind of your typical programming structure would be when my device starts up, when it connects to my IoT application, pull down the latest device twin, and that's got the values I need. And then when your device reboots, it'll do the same thing, pull down the device twin. So I can pull it as many times as it's like. It's stored as a JSON blob in the cloud, and you just retrieve that JSON blob. So you can retrieve it as many times as you like. It's not a message, it's a persisted state. If it was a message, then you could kind of lose those, but this is persisted state. What does zero dev? Does that make sense? Yeah. Sent once, periodically read, potentially read multiple times. Yes. Yes. Not really sent. Saved in the cloud once with a notification sent to the device. Makes sense. Excellent. Thank you, what a zero dev. So let's do this. We're now going to open up a different project. So go in here. Let's stop that. And let's open the next lab. Open folder. Lab 3, device twins. Load this up. Now, got to do my same at manifest changes. So copy those. Drop that in there. Copy my scope ID. Drop that in there. And let's just format this because it makes it look nicer. There's all my. So again, I've opened up a new lab folder, new content. So I'm just setting all my allowed stuff. And then I just have to go and, starter kit revision 1. And I'm using 22.02 is the operating system version with API set 12. And then I've got to just change that. So it's all been updated as we speak. It might already be updated. I just haven't actually got the latest one yet. So just because there's been a new release of the Azure Sphere OS. If I pushed an older version of the Azure Sphere OS to my device, I wouldn't need to do this. There we go. So now I just need to get CMake to reconfigure all the things, and that should get rid of all my errors. Now, I'm no expert with CMake at all. In fact, I don't even know how to use CMake. So a lot of this is me going, this doesn't work. Let me find the thing and fix it. I'm actually planning to do a series next month all about C++ and try and dive into some C++ dev. So let me know if that's of interest to you. But yeah, I'm hoping to spend a few weeks just playing with some C++. I used to be a really good C++ programmer, 15 years ago. But not anymore. And I'd certainly not update the new tools. So I'm going to do a series next week kind of playing with some of the new tools. So if that's of interest, let me know. Right, so we're all ready to go here. So our development port configuration. And then start the app. So let's actually start the app. Ready. Let's go. So again, we are building. The little light will start flashing. This is updating all the things. Should maintain all our Wi-Fi connection. And so give that a second. It's currently deleting what was there before. Albeit slowly. Yeah. Talk amongst yourselves what deletes the thing. But yeah, it's deleting the firmware, reinstalling it. So one thing about microcontroller based development is you don't get that same fast loop that you get with a lot of other applications. Like Python, you stop it, change the code, run it again, and it just runs. It's interpreted code. With microcontrollers, with C++ code, you've got to recompile the code. So you've got to delete the application on the device, recompile the code. And that is taking too long. So you know what? All else fails. Unplug it and replug it in. And just try again. Nope. Something is not very happy. Can I just stop that? Try again. Something is definitely not very happy. Did I break my hardware? You know what? Let's just stop this. Let's just kill that. Just run a command on my Azure Sphere device. Let's try that again. Because I wonder if somebody's got a bit unhappy. Let's try that again, let everything load up. Just make sure it connects to my device. Maybe I broke my hardware. Oh well. Okay, but we are at time. This has been this has flown by. So if this was working, so yeah. Click run this. Okay, I think now is a good time to stop because I think I may have broken my board. It's just blocking it, deleting existing applications, so I might have to wipe my board. But now's probably a good time to wrap it up. So yeah, over the past 2 weeks, last week and this week, we talked about Azure Sphere, talked a bit about security of it, and just kind of started working through this Learn module to try and see whether we could get Azure Sphere working. Didn't get as far as I would have liked, but we've had a lot of good discussion. Had a lot of fun with this. So, yep, links in the chat if you want to have a go yourself. aka.ms/secure IoT Azure Sphere. I don't know what supply chain is like at the moment for Azure Sphere boards. I know it can be. Some boards are very hard to get at the moment. Raspberry Pis are rarer than hen's teeth. But yeah, if you want to get a board and have a play, let me know. And then, yeah, let me know if this was fun, if you want me to run some more streams later on, carrying on with where we got so far. But otherwise, thank you very much for joining me.
Thank you, Jim, and thank you, everybody. If you have any feedback, we'd love to hear from you. Our survey is in the link. The event code for this specific event is 15784. We'd love to hear what you have to say. Until next time, thank you so much.
Cool. Thanks, everyone. Bye.
Have a good day.